My name is Lucas, and
my name's Roan, and we'll be talking about the Trustable Software Framework for ensuring integrity with open source-based systems. So Lucas will run through the rationale and a bit of an introduction, and then I will talk about a bit more of a deep dive into some examples and some use cases that we've used this on, and then Lucas will finish off looking at it for an application.
yeah, and before we start, what do you think when you say we are checking the integrity of a product, or even with your work? Do you think that do we need something to help us to define how complex software should behave, or can we guarantee some multi-core hardware environments the behavior when we are looking at them? Can you be sure, for example, that you know the behavior of your product all the time? It's hard to always say the correct behavior, but you can have a guess and try to guarantee that it's always going to be the same. And at the same time, we need to think about the safety standards that we are trying to be in compliance with our product. Sometimes they are only focusing in certain aspects of it. They just think about the hardware fault, and they ignore the random behaviors that we can, the environment can introduce, or even some piece of software together can make them coexist and impact your whole idea about how the system behaves. And of course, if you think about the complexity, sometimes it's not really easy to check. So as a result, sometimes software are not safe, secure, and of course, I don't know a software that is bug-free at all. I mean, I don't believe software can be bug-free. Okay. And the idea is achieving 100% confidence in most of the software is not really realistic. So how can we do better about it? First thing, if we have requirements, ideas, what software should do, we should control version them since day one. So we can know if something changed when we are over time, like our initial requirement wasn't correct, so we know when it changed. We can maintain integrity from a single source of truth to reduce ambiguity. And the best part, when you have different things working at the same time, you can always keep auditing and tracking the change in a way that we know when that can happen and how and when, and in an efficient manner without having to ask every single group or every single person. And if you have documentation around it, we can always keep them up to date with checks or anything. And also, we can, from time to time, review them and adapt to match new requirements. And we can also prove that whatever we are doing, we can connect them from links to from our requirements to implementations, and also verify if they are true and they are correctly. And also show how the progress from the concept of our idea to the delivery of our product or our package is connected to every single piece of this software or product. And then let's think about it. If we needed to organize this whole thing, how we could do this? The first thing that we think as software engineers or close power users related to something to version control nowadays is Git. Git is quite popular and is the best. And I think if you don't like Git, well, we are in the wrong talk, sorry. Why we love Git for this kind of work? It's familiar to almost for every single engineer nowadays. I think for the around 15 years, Git is the most common tool for this kind of work. I remember when it was before, when we had version 1 and version 2 around FTP servers and so on and so forth, and a lot of, well, different tools for this purpose that wasn't reliable at all. Like, I don't want to get into this, but anyway. Git helps as a transparent tool, and it's also easy to engage because when we talk about Git, we are talking usually about GitHub at a minimum, or GitLab, or anything similar. So they are just GitForce with a nice interface to open changes, which is quite nice and easier for reviewers to engage with. It's easy to transfer knowledge. So when you are doing review, you have a fast cycle for feedbacks, and you can share the responsibility about something for approving, reviewing, so on and so forth. And one of the most interesting features is that you can always add some automation around your pipeline. Like you have concepts like CI/CD, where you can add some verification. Like when you are adding one change to your product, is this change breaking everything? Is what I hold as truth. Still true at the end. And the last thing about Git is nothing more beautiful than everything inside version control, where if you need to double check when it was a change, one change has happened to a file, you can always trace back to the beginning of it. So you know every single change and why they happen to it. And this is the most exciting thing for me, at least when we are talking about Git. Okay, but do you think Git is enough to help you to build your product in a same manner for documentation, checking if everything is working as you expect to, my requirements are right? Yes, but you would have a lot of discipline. And what if sometimes discipline is not enough? And if you want to have something to help you to be in compliance with different standards like ISOs, IECs, or even different kind of standards like CRAs, ITU, COBIT, or whatever. And you don't want to be locked into a specific vendor like GitHub or GitLab. You just need something like, I need a Git repo and something to execute my CI/CD. And if that thing could be open source, and if that thing could be even extensible with, I don't have my AB piece to do what I want, but I do have I know something that maybe can help me, made by someone else that I can adapt to my use case. Something that can be created from your community around it, this tool, and you can even reuse as it is if you need to. And then we introduce you guys Trustable and the Trustable Software Framework. With Trustable, we want to achieve something that helps us to analyze behaviors from software in specific use cases. We want to analyze what could go wrong for those use cases as well. We want to plan something to fix, monitor, and even mitigate the problems that we find around it. We want to demonstrate that what we think about our product or software is defining a certain set of behaviors where we call, okay, we know what it does, and I can prove that they are always going to be true all the time. And if we find failures for our goals, how do we mitigate them? We want to demonstrate the mitigation in place, and how do we monitor that mitigation still works all the time? And also, we need to show how do we believe that our mitigation works, how confident we are on everything that I've just said. Just think that this is not one process thing. Like it's not just going to do once and I'm going to be safe all the time. It's something that you have to practice. You have to add to your pipeline. You have to repeat all the time. So it's something that should be practical, easy to use, and repeatable. So can we apply this? How can we apply this in a manner that it doesn't impact the workflow from day to day for software engineers or anyone that use Git as your guide, your product to store your content? So as part of framework, we are just going to focus on three aspects of it. We are going to talk about the model, where we try to express complex ideas, or focusing in certain elements or relationships. We have the objectives that defines what is important for our goal with this project. And Roan is going to talk around the tooling and how it works, the current implementation, to help us to achieve this goal. Let's talk initially, what is a trustable model? Trustable model simply is a graph of information that we connect and we describe their relationships. Basically, a trustable model is a set of statements which are connected by links, as you can see the image on the right side. We have statement X connecting to statement Y via link A. Links are just connections, logical connections, indicating the statement X implies the other, or the other. The set of statements also can, of a product and their linked forms, create a DAG, a directed graph, which means that easily they shouldn't be cycles around the graph. To remove any kind of circular, statements can be classified into overlapping categories, requests and claims. As you can see in the right side, I have a request X, which can be also interpreted as expectation. And and this expectation can be connected to another request or a new claim, which can also called assertion. And we have at the end connecting to a claim at the end. We also can be a premise. Statements can produce a combination of a trustable graph is just a combination of statements and links where you generate the model. And here is our way to describe your statement, the good practice for a trustable statement. Try to use indicative mood, third-person perspective all the time, present tense, make them always affirmative, stick to a single sentence when possible. Don't try to create complex things. Like, for example, look at the good examples. We have this trustable product provides a set of implementation in Python. It tries to be express if it's true what it does and what it offers. At the same time, a bad statement is when you just think maybe the trustable product should use Python, should use a different language. What about Python? The kind of tooling, do I need to specify the documentation? No, it should be clear. We use X2 for Y reason.
Okay, so I'll start talking about the actual Trustable Software Framework, and I'll ground some of the stuff that Lucas has introduced with some real examples. I'll first talk about the objectives of the Trustable Software Framework, the kind of objectives that we believe are applicable to all projects, and then I'll ground these and use some actual examples for some real projects that I've worked on. So the Trustable Software Framework is lightweight. It's meant to be implemented in your workflows already. I don't want you to be changing your workflows massively. We want you to be just using what we're doing to augment your workflows. So let me introduce some of the tooling. So here you can see TSF provides you the tooling to do this, so provides you the tooling to manage these graphs that Lucas talked about earlier, and we'll see some more examples of them soon, and provides you the tooling to produce these reports based on the graphs. So as someone who wants to know how my project is going towards its objectives and its claims that it's making towards safety or compliance with a standard, I want to be able to produce a report. Here is an example of part of that report. I'll get into some more examples in a bit. So the objectives, these are the objectives that we, the TSF maintainers, have come up with. We think these are applicable to general software projects, and they serve as a starting point. So individual projects may care about different things, but this serves as a starting point for you to base your objectives on top of. So we split these down into two categories, tenets and assertions. So without further ado, let me show you what they look like. So here you can see that graph structure that Lucas talked about earlier really starting to come into effect. We have the top level claim, which is this project, so XYZ is trustable. And then we break that down into what we think makes a project trustable. So these tenets here, provenance, construction, changes, expectations, results, and confidence, break that down further. And then below those, we then have assertions. So breaking those tenets down even further, and then allows you to really build out from that. Included in the TSF documentation is also examples and advice on how to evidence towards those claims and how to map safety standards on top of those claims. So this gives you a starting point, but obviously it's your graph for your project. You can change it as your project develops. So let's zoom in and talk about some actual real things as a developer. You know, I want to talk about some real things. So let's take one of the assertions. Let's take TA validation. And TA validation basically mandates that tests should have both normal and edge cases. Seems pretty reasonable. I'm sure that everyone agrees that we should both be testing our edge cases and our kind of normal expected paths. And so as someone evidencing that, as someone wanting to prove that that is true, I would then break that down further into I'm going to write an edge case test and I'm going to write a normal case test. And then underneath that, I may have the actual results of real edge case tests passing and the actual results of real normal case tests passing. So those are the red boxes behind me. Then, obviously, if I'm writing a test, I'm not just evidencing that part of the trustable graph, but I'm also evidencing some other parts of the trustable graph. So, for example, TA behaviours says mandates that required behaviours are identified and validated. So my test that my normal case is passing also shows that I'm validating one of my behaviours, my normal case. If I'm adding a project option and then I'm validating the normal case for that project option, then I'm validating that I've identified some behavior and then I'm validating it. So you can see here how from a test at the bottom, you're evidencing multiple sections of the graph because that's quite important. So if you change your test, you want to make sure that you've updated your behaviors to account for that as well. So putting all this together, we end up with a kind of feedback loop. So the idea is you start with your TSF graph with your statements, objectives, all of these things. This then links to evidence. Your evidence could be generated by CI, and then you do the validation of your graph in CI, and then that tells you where you're missing or what evidence you're missing, and then you go round the circle again, generate new evidence. That evidence could be generated by CI. You then put that into the trustable graph, and it identifies new areas that you're lacking in. So the idea that you're constantly feeding back and then updating your trustable graph and your overall score. So I'll ground that in a real example for a real project. So let me introduce the real project. So we use TSF on a platform project. So a platform project builds an image for a piece of hardware. And we want to make claims about that platform project. Platform projects are massive projects, so they integrate services, drivers, applications. They're huge things. For example, an entire Linux distribution will be a platform project. We have a platform project internally. We call this Control, and this is a Linux-based operating system which aims to produce a safety-orientated Linux-based operating system for the automotive industry. So Control is, as you can imagine, a massive project. It has many components which need regularly updating. It has many engineers working on it, and therefore we need to track our progress towards these claims that we're making about it and make sure that we're understanding the impact of any changes we're making to this project on those claims. So these are some real statements that I've pulled out from the control graph, just to give you some examples. So under TA releases, I have changes 3. So you can see that we number from this. You can probably guess that there are other changes, 1, 2 at least. But changes 3 says changes are not made by shortcutting or subverting the normal process controls, which I'm sure we can all agree is a good thing, and we should not be subverting the normal process controls when making software changes. And then I may have a evidence item, so changes evidence 11 supports changes 3, and changes evidence 11 says the GPC configuration for control ensures that a merge template is set. So that is helping us to not subvert the normal process control mechanism, because I'm saying that any changes to this project have to go through this merge request template that I've set. Another example, if we go back to the kind of test example that we had earlier, so we have an actual statement, so validation pre-merge, it says pre-merge test scenarios must include exception handling test cases. And then underneath that, we have specific actual fault induction tests that are linking and supporting that statement, saying, hey, look, I'm running these as pre-merge. Here are the results from pre-merge. Whether they pass or fail, I'm running them as pre-merge. So you can see how, for a project, you can start to build out your graph for your specific use case. So I've included specific technologies that we are including there. So GPC, which is GitLab Project Configurator? What? Configurator? Yeah, anyway, configurator. So where I'm including specific technologies that my use case is based on, building that graph out specifically for this project. So once it's up and working, these are actual reports produced by control. And you can see here, obviously, the report is humongous. The graph is massive, has thousands of nodes in it. And so some of here, at the top level, though, I can track my progress towards certain goals. So the score from these bottom items, if they're evidenced or not, bubbles up to the very top, and I can see an overall progress towards certain goals. And you can see here that we have both the compliance for Trustable, so these are the tenets from earlier, and we can see that I'm also tracking the compliance for control. So these are statements towards a safety argument and my progress towards them. So as a developer, day-to-day, what does this look like as an engineer on the ground using it? Someone that's going to be making changes to this project that's using this. So we'll go through 2 scenarios. We'll go through making a change to the project. So when I make a change, what do I have to do to continue that compliance and make sure that I haven't broken anything by making my change? And then we're going to talk about adding a new node to the graph. So this is actual screenshots I've taken. So say, I'm going to go through this example here. So you can see here that in my terminal, I've changed the CI system, so CI/CD system, from using Podman to using Docker. A change. I then want to understand the impact of that change and how that affects my project as a whole. So I run TrueDAG, which is the name for the tool for TSF. As I run this lint command to check if anything has been affected by the change. You can see here that I get this output, so I can see here that this specific item has been affected by my change. And so I've opened up that item on the side here, and you can see here that we have references and a score, and the item statement here. My head's kind of in the way of the item statement, but basically the item statement says that the control pipeline runs on the smallest runners with no internet access. So this, you can see, is unrelated to what container I'm running my pipeline in. But the way that this change detected that this was relevant is that I've referenced this file that I'm changing here. So any change to this file here would mean I would have to check all the statements related to that file to check that they're true. So I fully understand the impact and possible impact of making that change. Nowadays, we have slightly more advanced things, so you can reference specific parts of files and things like that, and that's an extensible interface. But the main point is that I've made a change to this file. I need to understand any statements or claims that I'm making that rely on that file and check that they're still true. As the person that reviewed this item and said that this is true at the moment, I can then set that item to true using the TrueDAG manage set item. I can add it, and I can commit it to my normal project. So for adding a new evidence to the graph, so I'm going to add a test to the graph. So here you can see the new test being added. And so I've added a fairly basic test. I'm checking for duplicate services have not started in error. Then I'm going to add a new evidence node to the graph that references that test. So this evidence node, I'm going to reference the test that I've written, so you can see that at the bottom here. And so any change to that test means that the person changing that test has to evaluate if my statement here is still true. And then I'm going to use the evidence item. So instead of having the manual score that we saw earlier, I'm going to automatically validate this. So when you run the test, this validator here is going to check the output of the test that it's true. And if it's not true, it sets the score to 0. And if the test did pass, it sets the score to 1. And so here are the terminal commands that I ran, not a massive amount extra. So I was going to create that test anyway. And now I've just created an evidence item to reference that test. And then I've linked it up at the bottom to the rest of the graph. So that obviously is not it's not a no workflow, like it adds some time to your workflow. So let's kind of evaluate this compared to some of the more traditional workflows when looking for compliance. So TSF workflow is to make a change. It required running a few extra commands. We had to view some files. For adding a new node, we had to create an extra file that we wouldn't have otherwise and run 2 or 3 extra commands. So the overhead is minimal, and it's spread across the entirety of the project's development. So I'm doing this as part of my normal workflow. I'm not adding a step at the end of my project development where I have to scramble and gather thousands and thousands of pieces of evidence to go for compliance for a safety standard. I'm collecting that evidence as I go along. I'm tracking my progress towards that evidence as I go along. And I can understand better where my current project is at and how far away from perhaps going for a certification I am, because I'm tracking progress towards that. So if you're in a more traditional workflow, if you are trying to do this as you go along, what this would actually involve would be chasing safety experts. Like if I made a change, I would have to chase a safety expert to assess the impact of my change and assess if I needed to collect new evidence. What this does is, with managing it as you go along, the experts can be less involved, and they can perhaps, if you need to add a new evidence node, they can review that new evidence node if it's critical, but if it's already been mapped out, then it's completely fine. So we've kind of seen how TSF works on like a platform project, on a big project. Lucas is going to talk about how it might work for an individual component project, which is a bit different.
Yeah, and also before getting into a component level, we should talk about the community around TSF. Currently, we have some work by the guys from Define. Do we have someone from Define here? No, okay, sad. We have also some work from Codethink in the open called Safety Monitor, which we apply TSF on this project, which is an older version, but it's still a good way to see this. And we also have some work around TSF with Daniel, is a part of the Eclipse Foundation member thing. The one that we are going to talk about as part of a TSF in a component, we are going to analyze briefly the work done by the Define guys in the new Nolaman JSON library. I'm not sure if you know this library. It's a well-known library, CPP library. which is a small library, doesn't have much dependencies, external dependencies. It's just a good set. It has a good test coverage. It is really extensive and well documented. And bear in mind that this library wasn't built with the safety in mind. It's just a JSON library to parse files, to create JSON files from the CPP context. So the first thing that they did was like, they added TSF to it. So they added the tenets, the assertions from Trustable Upstream to this product. Before applying TSF to it, they had to understand what were their goals related to what do I want to show, what is my evidence, what is a good test, or what is the result that I want to add as part of my TA, under TAs, and how should I collect this kind of evidence. And they learned the framework intrinsics, and also, as Roan said, he introduced your reference and validators. The TSF allows you to create your own reference plugin or validator to fit your own needs. For example, this is the repo. If you want, you can access the QR code to this specific version of the report. As you can see the whole trustable graph. You can see the compliance side for certain aspects of it, AAU, so on and so forth, which is defined by the product. And at the end, you can see some of the trustable work around it. The URL is at the top. And this is one of the items. I picked this one because I was quite interested when I saw the specific part of the JSON library they were analyzing and how they evaluate the upstream product, which is not how they see if there are some changes that they should be aware or not. So it's telling the whole process from the TA updates to around here and how they evaluate this thing. And as you can see at the end of the image, you see a certain reference to a website and explaining how they do, how they evaluate some aspect with one single sentence. And if we deep dive how they do this, it's a simple matter. They created one reference type for the specific needs. Like I don't have this type for my product. TSF doesn't provide something. Can I create my own type? Yes. And they created this specific type called product website, which just parses a given URL. And as evidence, they are collecting some response from this URL. And you have certain aspects like 2 seconds from a specific query. So they just evaluate this process. And if it's true, this evidence can have a good score. And at the end, you can also note that there is some explanation why, how it's evaluated. In this case, there are notes that there is no pushes from this library upstream. So it's fine. It's well known, it's acceptable, so the branch is the same as they are using. And now we got to the part where you can, if you want to see the details of how is it, the whole report or how the file is, you can go to this URL or this QR code to see the same file that I was presenting in the last image. Okay. And now I have a question for you. Do you have a product where you think is suitable for Trustable to help you to engage and show that what I'm doing, I believe is enough? Or can I show that my product works as it is for any kind of component? Think about this. I have a component that is not built for safety, but I think my component is stable enough or it's good enough to be used in one product as part of a big product like Roan said for a platform, anything. Do you think you can add Trustable to help you to guide into this direction? Do you have anything in mind? Really? What it does? Which kind of project is this one? I don't know, to be honest. Yeah. No, sorry. Oops.
Yeah, Eclipse Rich Client Platform.
Mm-hmm.
Yeah, is a Java-based application development platform. And the final application actually would need something like this to show it applies to or it fulfills whatever NIS2, CRA, things like that. And to start with, I think it should make sense to have Eclipse Rich Client Platform as such to show it complies to these requirements.
Okay. Do you have any other? I mean, bear in mind that it's not only for safety or even for specific ISOs or IECs. You can also think about the product for a CRA or even for your own organization as well. Yeah.
I have no project, but actually a generic answer which may lead to a question to you, okay? So any project where we have regulations, such as actually you mentioned CRA, safety, AI Act, Data Act, where you need to make available evidence that might be checked, would have this in mind, okay? So my question to you is, probably this is the intent of your project, whether we can also categorize them. So now this guy is focusing on cybersecurity, but the other guy is focusing on AI Act. So they add the additional things to your system so that they produce the evidence, and the evidence are dispatched according to the needs.
Yeah.
Is that the intent of your system?
Yeah. So something we are working on at the moment is publishing reusable argumentation. So if you are trying to be compliant to something like the CRA, we would have a set of default argumentation that builds on top of the Trustable foundation that we talked about. And then you, as someone trying to be compliant to that, would consume that as your base. And then it would help you organize your own argumentation underneath that, so collecting your evidence specific for your project.
So we're interested to check and how this can work smoothly. Yeah.
Yes.
Definitely it's a need, by the way. So we hope that this can be a success in that direction. Yeah.
Awesome.
Thank you, very interesting. So following up on that question, in the specific use cases of safety, which of the safety standard have you tried to apply this to? I think your abstracts suggest 61850, but have you applied something else into railway or automotive? And following up on that, do you see the opportunity to working with some of the standardization body to provide templates that you can use for each of the safety standards so that adopters can just have a building block to start from?
So we have a mapping of the TSF to IEC 61508, and we have been told that that mapping is then sufficient to cover ISO 26262. So we have applied TSF towards that, and we have a safety body that has agreed that that is a valid and reasonable approach, and we're looking to apply this to other ones as well.
Is that mapping available as part of the open source project or not?
So
have to give the email to?
Sorry. Okay. We did explain our long-term mapping effort. So the long-term mapping effort, 61508 first. We just did yesterday, we talked about CRP, which is the, EDP, the Eclipse development process itself. We did another mapping. Actually, Daniel from ETAS did another mapping, which is now being made public. And we have requests and plans for 26262, DO 178, IEC 31, whatever the consumer good device is. So we're showing you how to do mappings. And the purpose of doing it is if you then aligned, as the gentleman we're talking about, as Roan and Lucas were talking about, if you actually assess to TSF, what you would do is you say, I want to assess to TSF. The first question from the assessor is, what mapping? You would then adopt the mapping, 61508, 26262, whatever, and now you just apply your TSF. What you get is the actual cert from, so you get an IEC 61508 cert or an ISO 26, so you get the cert you want, but the manner in which you're doing it is instead of following proprietary, confidential, contract-covered spreadsheets from different assessors, you follow an open process and get the actual cert on the outside. Yep. And all that is open, and our long-term goal is to put it in the project fully open. But right now, we haven't got our own cert, so we're holding it, but it is an early preview, and you are free to see it, comment on it, use it, etc.
Yeah, I understood that this is coming from 2622 IEC 61508, things like that, but the problem is very generic, okay? So if we are able to express what you express in a very generic way, and we can standardize this, okay, as a framework, then you contextualize according to the needs and the verticals, and actually the characteristic. Safety, cybersecurity, interoperability, trustworthiness. So we need to have this kind of framework. And this tool could be the one that shows that you can implement it, yeah? So we need to go into that direction.
I completely agree with the gentleman. So also I'm from Codethink here, and I was helping facilitate a workshop yesterday that was just precisely on this point. So Codethink has successfully, through client engagements, already been using the TSF and the associated methodologies with 9001, with piece-by-piece assessments, with ISO-PAS 8926, that illustrates that ultimately it is the general nature of this methodology can be applied to many, many different contexts, to the point that the gentleman's made.
So since Frédéric there, we can try to come up with some ideas where we can promote this framework and standardize it. Yeah. Maybe SC7, software engineering, maybe elsewhere, I don't know, but let's discuss it, okay? Mm-hmm.
Thanks. We have the next presentation starting, so we do have to wrap up.
Awesome. Okay.
Thank you.